Ladies and gentlemen, boys and girls, children of all ages, your attention is focused on me as we talk about using models when we're multiplying decimals. Now, you've already previously been taught if we did 3 times, 7/100ths. You've been taught how to use a model for that. That just tells you that you're coloring in 7/100ths 3 different times. So I would go, here's one of my groups of 7/100ths. Then I have 3, 4, 5, 6. Here's my second group of 7/100ths. And then a third group of 700. 1, 2, 3, 4, 5, 6. So this would be my third group of 7/100ths. Now we know the whole entire square in this is valued of 1. We know each row or column are valued 1/10 or 0.1. And we know each itty bitty little square is 100. And we know if we divided each of these itty bitty squares into 10 equal pieces, each of those equal pieces would be 1,000. I know. All right. So if we're multiplying by a whole number, by a decimal, this tells us how many groups. Tells us how many have to be in each group. And then I counted. I have 10, 20, so 1/10, 2/10. And 100th, so that would equal 0.21. Sorry, 2/10, because I have 2 complete columns shaded in, and then 1 little extra one. So that means I have 100th shaded in. Make centavos. All right. Now, one of the problems you had on the spot review last week gave you a picture, and it said you pick which equation matches this picture. And let's say if we had 7/10 times 6/10. Anytime we're using a visual to multiply, and they give you this grid and they give you a picture, you're probably going to be given the grid and the picture and telling you which equation matches it, just like we had on last week's spot review. Well, anytime they do that, you're going to be multiplying tenths, and you're going to get an answer in the hundredths. Now, the way this works is you take your first factor, which is 7/10, and we're going to, ideally, we would shade in this 7/10, but I want you to be able to see it. You take your second factor, which is 6/10, and you do it the opposite direction. And then your answer is how many hundredths are shaded in. And in this case, there are 42 hundredths shaded in. And we would do that just by counting them. Always, the factors are tenths, and the product is hundredths when they're doing it like this. Now, I could show you the standard algorithm because we're going to get into that. So if I showed you the standard algorithm, when multiplying decimals, we rewrite it. We ignore the decimal points. And obviously, if we're rewriting it, I wouldn't put 0.7 times 0.6. That makes no sense whatsoever. So I have 7 times 6, which is 42. Then I go back and I count how many numbers are behind the decimal point in the problem. There are 2 numbers behind the decimal point in the problem. That means there needs to be 2 numbers behind it in the answer. So we get the same thing, but I'm just showing you the standard algorithm. But the key is to recognize that they're going to give you a picture like this, but it would be shaded a little bit, and you'd still be able to see this even though it's shaded in both colors, and that would be your answer. But it's always tenths times tenths equals hundredths. Let's look at a couple more. Oh, let's look at 9/10 times 3/10. You could probably already tell me what the answer to that is, right? 27 hundredths. Okay? But the picture would look like 9/10. Oh, geez, that's way too long. And 3/10. I'm doing something. Oh, I did it the same way. 9/10 and 3/10. And then my answer would be how many ever are shaded in both. This would be shaded in both the pink and the red. This would be shaded in both the pink and the red. So that is how I would find the answer. It would be, there's 27 of these that are shaded in for both colors. Now this should look familiar to you because there was a video over this on yesterday's assignment. And I don't just put the videos on there just to waste your time. I'm trying to put videos on there to preview what we're going to do so that by the time I get to teach it, you've got a little bit of an idea of how it goes. And it's the second or third time you've heard it. So those videos on there are important in my mind anyway. I mean, I'm just trying to help. What do I know? What if we had 5/10 times 3/10? You already probably know the answer is 1500. The picture would look like 1, 2, 3, 4, 5/10. And this would be shaded in. And I'm not shading the whole thing in. And then we would have 3/10 shaded in this way. And this would be shaded in with both colors. And so what's in here would be your answer. And yes, it is 1500. The key is, I'm going to say it again. If they give you a picture like this, they're probably going to say which equation goes with it. And you're going to have to look for the tenths, and the hundredths. Now, if they gave you this exact problem, every answer choice would have a 5, a 3, and a 15. Every one of them. But it might say 5 times 3 equals 15. It might say 5 hundredths times 3 hundredths equals 15 hundredths. But the same numbers are going to be in there every single time. But if it's like this, that's 5/10 shaded in because each row is worth a tenth. That's 3/10 shaded in because each column is worth a tenth. There are 15 that are shaded in by both, so those are each worth a hundredth, and that's where your answer comes 15 hundredths. It's really very simple. You just got to think. Now, I've already attached 2 videos of a lesson I did like this. Yesterday, you watched a video of a lesson I did like this. I will soon attach this video of this lesson to today's Google Classroom. And you'll be able to see it. You can always go back and look at them. They're there because I care. Boom, shakalaka, peace out, God bless, love you, do something kind today. Please subscribe.